Let us understand how we can repartition the existing partition table using range partitioning strategy. We will use users underscore range underscore part table. It is originally partitioned for each year. Now we would like to partition for each month. Here are the steps that are involved in repartitioning from year to month. First, we have to detach all yearly partitions from users underscore range underscore part. Then we have to add new partitions for each month. Then using the data from detached yearly partitions, we have to load data into the table with monthly partitions. Once the data is loaded, we have to validate by running simple queries against the table to ensure that data is copied appropriately. Then we have to drop all the detached partitions. These are the high level steps which we need to follow. When it comes to monthly partitions on our table, we will end up having 60 partitions because our original table has 5 yearly partitions. And it is not a good idea to actually use 60 create table commands to create tables for 60 partitions. Instead, we should automate it. I'll be demonstrating using Python based approach. Based upon your convenience, you can use the programming language of your choice and you should be able to automate creation of these 60 partitions instead of having 60 create table commands for 60 monthly partitions. Let's load the SQL magic. Let's define database underscore URL environment variable for my Jupyter Hub environment to connect to the database when we run the queries. Now this is how we can detach all yearly partitions. We have only 5 and hence I am having 5 alter table commands like this to detach all the 5 partitions. If you want, you can even automate this. When it comes to adding 60 monthly partitions, I am using Python based approach here. Python have a library called as pandas. Using date range function in pandas, we should be able to create a range of months. So this actually take care of giving us 3 monthly dates with begin date and end date, because we have specified start as January 1st 2016 and end as March 31st 2016 with the frequency 1 month. So we are trying to get 3 months as a list, and also we are trying to get the beginning date of the month and end date of the month, because while creating the range partition using create table command as part of for values from and to, we have to give the beginning value and ending value for that range partition, and hence we are trying to get those values. This is the simple code which will take care of that. In this case, we are just printing the beginning date and ending date for each of the 3 months, 2016 January, February and March. You can see here. Using this, we will actually fine-tune our logic to create all the 60 partitions in an automated fashion. So I am saying months equal to pd.date range, start equal to January 1st 2016 till December 31st 2020 with frequency 1 month. So this will give us the 60 months. However, to get the ranges, we have to use similar logic. You can see here I am using something called as month begin, month end, etc., which is part of pandas t-series offsets, and we should be able to get the beginning date of the given month and ending date of the given month. Using this information of month, beginning date and ending date, this is how the create table command look like. So we are just saying create table, table name underscore monthly partition, partition of the main table. Then for values from begin date to end date, all these values has to be dynamically generated for each and every month, and that's what is taken care as part of this loop. We are just using this query as template and replacing these placeholders with appropriate values, and it will take care of creating all the partitions for us. Make sure you commit the code whenever you use Python based approach. You need to ensure that the transaction is committed, otherwise you will not be seeing the partitions in the database on top of the table on which we are trying to create the partitions, because in Postgres DDL commands are not auto committed. In other databases, even if you do not commit, when we execute DDL commands, you will see the results automatically. But with Postgres, it is not auto committed. And whenever we use a programming language to connect to the database, it need not be auto commit from the libraries we are using. We might have to explicitly commit. That's why we have the commit here. Then we are closing the cursor and connection, which is typical with any programming language. I don't want to get into too many details with respect to Python here. Just you need to understand that I have a template here to create the partition tables, and we are replacing the placeholders while executing the query here with the month, the begin date and end date, as well as the table name, which is nothing but users underscore range underscore part. Now let me run this. I have to import this also. you might not have this library. If you do not find this library, first you need to install that library. I have already installed this library earlier. That's why it is saying it is already satisfied. So first you have to install this library, then import this library. Then you have to run this piece of code, which will take care of adding the partitions for us. You can see here, it is saying adding partition for a given month with begin date and end date. The reason why it is printing like this is because I am printing as part of the loop here. So before creating the table for our partition, it is actually printing this message. Now we should be able to insert the data from our yearly partitions into the table users underscore range underscore part. We have 5 yearly partitions which are detached. Using those detached partitions, we should be able to insert into the main table. Based upon the data, it will go to the appropriate partition automatically for us. So I am running these 5 insert statements. We don't have any records for year 2016. That's why it is saying 0 rows affected. As part of 2017, we have 1 record. That's why it is saying 1 row affected. As part of 2018, also we have 1 record. As part of 2019, also we have 1 record. As part of 2020, we do not have any records. So all the 3 records from the detached partitions is inserted into the monthly partition table, and the records will go to the appropriate monthly partitions. You can run this query to see all the 3 records in the main table, which is nothing but users underscore range underscore part. Then you can see the date here for user ID 3. The created date is 2017 June 22nd, and hence the data should be there as part of 2017 June. You can run this and you can see the record here. For user ID 1, the data is in 2018 October partition because the created date is 2018 October 1st. You can run this and you should be able to see that record. For user ID 2, the created date is 2019 February, and hence the record should be now in 2019 February partition. This is how you should be able to validate to ensure that repartitioning is successful. As we are able to see the data in the monthly partition table in appropriate monthly partitions, we can drop the tables which are created earlier using yearly partitioning strategy. They are already detached from our main table, and hence we should be able to drop them like this. To ensure that we have all the tables that are created for our partitioning strategy, you can run this query against information schema tables, and you can see all the tables with respect to our monthly partitions here. We have 61 of them because we have default also. So from 2016 January to 2020 December, we have 60 partitions or 60 tables for 60 partitions, and then 1 table for the default partition. That's why we have 60 of them, and the last one is nothing but default. So this is how you should be able to repartition. This is quite common task wherever the partitioning is used to repartition the data. Sometimes you might want to ensure that data in the default partition is partitioned further. Even as part of that effort, we typically detach the default partition, copy the data into the more specific partitions, and then truncate the default partition table and attach that table again to the main table. That's how we will typically manage the default partitions. We have seen an example with respect to list partitioning earlier. Now we have seen how to repartition the hash partitioning. So this is how you should take care of repartitioning of the tables whenever you want to repartition using a different strategy than the strategy which was used earlier.